Hello students, in this video we learn about the Bayesian belief network. This Bayesian belief network is based on the graph probability theory, which consists of directed acyclic graph and a conditional probability table. In this example, you can see that there are nodes as well as arcs. This arcs represents the relationship between the different nodes that are available, and also it consists of a conditional probability table. Now, if you look at this rain node, it is having a parent node which is called cloud. And if you look at the wet grass, you can see that wet grass is having the two parent nodes which is called sprinkler as well as a rain. And we can also see one conditional probability table, right? If I want to know that it is rainy, but there is no cloud. So here using this table, it is rainy but there is no cloud, right? So it means that the probability that it is it is not cloudy but it's raining is 0 0.2. In the same way, if I want to know it is rainy as well as it is cloudy, the probability will be what? 0 0.8. Right here in the wet grass, you can see that there are two nodes for the wet grass, two parent nodes, that is sprinkler as well as rain. So if I want to know the probability of wet grass where it is due to sprinkler and where it is due to rain, that will be what? 0.99. Okay, so here it is sprinkler and it is rainy, but the grass is not wet. What is the probability of that? We can see that it is 0.01. So in this way we can make different conclusions. So using this nodes, that is directed acyclic graph and conditional probability table, it allows us to draw many conclusions or the outcomes. So here this Bayesian belief network, it is dependent on the joint probability distribution. For example, if you are having some variables like a1, a2 to a3, and the combination of this three different variables will give you the joint probability distribution. So look at this variables. So we are having different variables like a1, a2, a3 to an, right? So in that, if you want to find the probability of a1, so a1 with respect to the other variables, that is a2, a3 to an. Similarly, we need to find the probability of a2, and then we need to find the probability of a3 with respect to the other variables which are present. So we can find that till it reaches to the n minus 1 elements. Then we'll multiply that with the independent elements or independent variables that are present. And now we can simply write this equation as the probability of xi, which refers to the different input features and the parent of that xi. If it is having any parent node, will be given with that parent node. If it is not having any parent node, it is just taken as an independent node. Now let us understand this with an example. Here in this example, we can see different nodes like admissions, marks, aptitude score, IQ level, exam level, and all. So this is having various conditional probability values. Okay, so it is from this we can calculate the joint probability distribution. So here we are having 5 nodes, so that in that 5 nodes we want to know whether the person is taking the admission into your university or not. So to find that, it is dependent on other levels like exam level, marks is again dependent on the exam level and the IQ level, and aptitude score is also dependent on IQ level. It means that marks is having the two parent nodes like exam level and the IQ level. So admission is having one parent node, marks, and aptitude score is having the parent node which is called IQ level. So for this we can draw we can calculate the joint probability distribution as, so admission is having what? The parent node as marks, and marks is having the parent node exam level as well as the IQ level, and the aptitude score, it is having the parent node as what? IQ level. and this exam level and the IQ level are independent nodes. So we need to calculate the probability of this exam level as well as probability of the IQ level. So this is the joint probability distribution which is derived from the given conditional probability table and the directed acyclic graph. Now, using this joint probability distribution, we can answer for various problems. So here let us understand a problem like here it is like calculate the probability that despite the exam level being difficult. Here it is given that exam level is being difficult and the student is having the low IQ level. IQ level is 0 and here exam level it is given as difficult which is taken as 1. IQ level it is 0 and low aptitude score. So aptitude score is 0. So, even though he manages to pass the exam. So he cleared the exam and secured admission to the university. He got the marks and he secured admission to the university. So based on this, now we can create the John probability distribution. So here in the John probability distribution, which we have drawn, which we have derived it from the node and the different nodes and the conditional probability table, we can use that to get the outcome. So here we know that from the diagram, admission is having a parent node which is called marks and marks is having the parent nodes like exam level and the IQ level, right? And also score aptitude score is having the parent node IQ level. And we need to find the probability of independent nodes, that is IQ level as well as the exam level. And now to calculate the probability, here it is given as admission as 1 and the marks as 1. When we look at this conditional probability table, when admission is 1 and marks is 1, we have the value as what 0.1. And then similarly, when you have considered the marks, mark should be 1 and the IQ level is 0. IQ level is 0, exam level is 1 and it is given marks as 1. So you get the value of 0.1. In this way, we're using this conditional probability table. You can calculate the all the probabilities that are there and finally you get the joint probability distribution of this given problem statement. Now, let's see one more problem statement which we need to find the probability of a student who is having high IQ level. His IQ level is high and the aptitude score is also high, but the exam is being easy, so which is considered as 0, and he fails to pass the exam. So marks he got is 0 and it does not get into the admission. Now we need to find the joint probability distribution of this. Similarly, using that derived joint probability distribution, we this marks is having the two parent nodes. So here again we'll consider this IQ level as 1 and exam level he did not pass the exam level, so we'll take it as 0. So in this way, after substituting the probabilities of this, so for here the given that admission is 0 and the marks is 0. So we'll check it that in the probability table. When admission is 0, we see that when marks are 0 and admission is 0, the probability given is what 0.6. So in this way, we need to find the probability of all the joint probability, total joint probability distribution. Then we'll get the joint probability distribution value. So in this way, we can derive the output for various problem statements. Thank you.